Okay, everybody, we are starting into our algebra unit. Now, today's lesson, everything that we're going to cover is going to be super easy, and I'm willing to bet that every one of you could do all this stuff without algebra in your head. And that's great. Okay? That's fantastic. The problem is this stuff is easy. Okay? Not even going to lie to you. Easy. But what we're going to get into in 4.3 is not. And I guarantee you, you will not be able to do 4.3 in your head. And it will be because you haven't stopped to figure out how to do 4.1 using the algebra methods that I'm going to outline for you today. So even though it's harder than how you know how to do it already, use the algebra today. Now, the whole reason that people find algebra difficult is that it's a game of opposites. It's actually exactly backwards to what we're used to doing. Usually we have a problem and we work forward towards a solution. Well, in algebra, we know what the equation is, we know what the relationship is, so we already have the solution. What we got to do is work backwards to find what the initial conditions are. To do that, we use algebra. We have to think of the equation as a balance with an equal sign as the pivot points. In order to keep the balance, whatever you do to one side must be done on both sides, right? If we were to throw 5 on one side and not on the other, it's not going to balance. We have to have 5 and 5 to keep that balance, right? Thinking about a regular scale. It's not quite that simple for algebra, but that's essentially the concept that we're going to be working with here. Now, inverse operation is what we do, is how we keep things balanced. And inverse, come on, is a fancy way of saying opposite. Okay, so whenever I'm talking about the inverse operation, what is the opposite of the operation that's on the page? And what are operations? Well, these are your operations. Okay, addition, subtraction, multiplication, division, squaring something, and square rooting something. Those are the basic ones anyways. There's definitely other ones out there. We're not going to worry about those for now. So the opposite, the inverse of addition is subtraction. The inverse of subtraction is addition. Inverse of multiplication, division. Inverse of division, inverse. The inverse of squaring something is square rooting something. And the inverse of square rooting something is squaring something. And you should be familiar with all of these. The square and the square root might be a bit of a challenge, but you would have used it in Pythagorean theorem, so you've definitely seen it. The biggest difference is that I'm going to start calling it the inverse instead of doing the opposite. Now, you're going to hear me refer to an inverse operation as moving things to the other side. Okay, so again, thinking of the equal sign as the pivot point on a balance beam, you have to use inverse operations to keep the balance equal. So if you look at the diagram here, you're going to see that we have a -2. Come on. So the opposite of subtracting 2 is adding 2. So the inverse is adding 2 to the left side. But the problem is if it's only on the left side, we're out of balance. So we have to do it to both sides. To stay balanced. Ran out of room. Sorry, guys. I'll fix that up in the final copy. So what does this look like? So the short version is what's happening, what's the opposite of it? So here we have a +3. The opposite of +3 is -3. And most of you have probably been taught to write it like this. I tend to throw the underline in there just for teaching purposes so that you can see what it is that I've done. X +3 -3, well, that cancels out and just leaves X. 9 minus 3 is 6. Okay, here we have 4x times 4x equals 20. No sign. Hopefully you remember this from our integer, not our integer unit, our collecting like terms unit, the polynomial unit. When there's no sign, it means that the numbers and the variables are being multiplied together. So the opposite of multiplication, whoa, is division. Oops, jumping right to the final answer there. Don't do that, you'll get the answer wrong. And I'm doing it again. Be smarter than your teacher is. Okay, again, what's happening? We're dividing by 2. The opposite of dividing by 2 is multiplying by 2. All right. Now, where it gets a little murky, most people are going to want to add 8, but the problem is that negative sign. What's the opposite? The opposite of negative 8 is plus 8. Now, many of you are probably sitting there going, oh, what the heck? That makes no sense to me. And yet, let me finish writing this out here. If I were to turn around and rewrite this out like this, none of you would question me. And it's the same thing. That negative sign is a subtraction sign. That subtraction sign is a negative sign. So when it moves over so that we reverse it, there's an imaginary plus sign in front of the x that we never write down because we just assume it's positive if there's no sign there. But it matters if we were to move that negative 8 into a different spot. Okay, so it's not necessary. It's not the sign. It's not just the sign between the terms that are important. It's the signs that's with it. Now, multiplication, you don't ever have to worry about this. This is only an addition subtraction conundrum. Clear as mud? Perfect. Cool, I've already pre-written on this page. So do your best to use proper algebra in this section. Don't cheat, because as I said, the work that's coming is going to be, it's going to be harder.